The general form of quadratic equations, ax squared plus bx plus c equals 0, and the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So let's apply that to an example. So we're given x squared plus 4x minus 21 equals 0. And we need to solve this. So first we need to identify our a. Our a is going to be 1. Our b is going to be 4. And our c is just going to be negative 21. Plug it into the quadratic formula. So we'll have negative 4 plus or minus square root 4 squared minus 4 parentheses 1 parentheses negative 21. All that over 2 times 1. Now our task is just to simplify the radical. So we'll have negative 4 plus or minus square root 4 squared is 16. Then we have 4 times 1 times negative 21. So that's going to be a positive 84. All this over 2. So we're going to have negative 4 plus or minus square root 100 all over 2. The square root of 100 happens to be 10. So we have negative 4 plus or minus 10 all over 2. We're going to divide both the negative 4 and 10 by 2. So we have negative 2 plus or minus 5. We're going to separate this into two answers. Negative 2 plus 5 and negative 2 minus 5. So negative 2 plus 5 is going to give 3. And negative 2 minus 5 is going to give me negative 7. And we're done. If we want to confirm that answer in using a graph, we'll just type the equation in. So we'll use Desmos for that part. X squared plus 4x minus 21. And we want to know where the zeros are. Our zeros are negative 7 and positive 3. And those are the same two zeros we got using the quadratic formula. And we're done. Example 2. We're given the problem 3x squared minus 6x equals negative 10. So first, before we can even solve it, we have to add 10 to both sides. So we're left with 3x squared plus 6x plus 10 equals 0. So we're going to identify our a. That's going to be 3. Our b is going to be 6. And our c is going to be 10. Plug everything into the quadratic formula. So it's going to be negative 6 plus or minus square root 6 squared minus 4 times 3 times 10. All this over 2 times 3. Simplify the radical. So negative 6 plus or minus square root 36. 4 times 3 is 10. 4 times 3 is 12. Minus 10 is going to be 120. All this over 6. And then just do 36 minus 10. We'll use 36 minus 10. Happens to be, 36 minus 120 equals negative 84. So we have negative 6 plus or minus square root negative 84 all over 6. So when we have a negative under the radical, like we have here, there's no real, there aren't any real roots. So for this video, we're going to just focus on the positive roots. So just to see what this looks like, we're going to just type this into Desmos. Just clear out. We have 3x squared plus 6x plus 10, and we can see that this parabola does not touch the x-axis at all, so that just shows that there aren't any real roots for this problem, and we're done for now. We'll hit the imaginary roots in the next video. Example 3, we're given negative x squared plus 8x equals 1. So just like in the last example, we have to subtract 1 from both sides so they equal to 0. So we have negative x squared plus 8x minus 1 equals 0. So our a is going to be negative 1, our b is going to be 8, our c is going to give me negative 1. So quadratic formula, negative 8 plus or minus square root 8 squared minus 4 times negative 1 times negative 1. All this over 2 times negative 1. Simplify the radical. We're going to have negative 8 plus or minus square root 8 squared is going to be 64. And then 4 times negative 1 is negative 4 times negative 1 is be positive 4. So minus 4. All this over 2 parentheses negative 1. So we have negative 8 plus or minus square root 60. All that over negative 2. So 60 you want to try to break down. 60 can be broken down into 3 and 20. That can't be broken down any farther. So that's as far as we can go with that one. So we just want to confirm our answers. So we can remember we can write this as negative 8 plus root 60 all over negative 2, or negative 8 minus root 60 all over negative 2. Let's check our answers using the graph. So first, we'll enter the equation, negative 8 plus root 60 divide negative 2, and then negative 8 minus root 60 divide negative 2. So we got 0.127 and 7.8729. Let's type the original equation in and just check our answer. So negative x squared, negative x squared plus 8x minus 1. And let's look at the intercepts. So negative 0.127, exactly what we have for our first option. And then 7.873. If we round the 7.8729, we round the 7.873. So we solve this one correctly, and we are done. In example 4, we're given negative 3x squared plus 10x minus 3 equals 0. This time we don't have to solve set equal to 0, just identify A, B, and C. So A equals negative 3, B equals 10, and C equals negative 3. Plug into the quadratic formula. We have negative 10 plus or minus square root 10 squared minus 4 times negative 3 times negative 3. All this over 2 times negative 3. Simplify the radical. We have negative 10 plus or minus square root 100. Negative 4 times negative 3 is going to be negative 12 times negative 3 is going to be a negative 36. All this over negative 6. Keep simplifying. Negative 10 plus or minus square root 100 minus 36 is going to be 64. All this over negative 6. Square root of 64 is going to be 8. So we're going to have negative 10 plus or minus 8 all over negative 6. So we'll have negative 10 plus 8 all over negative 6, or negative 10 minus 8 all over negative 6. So negative 10 plus 8 is going to be, we'll come over here and finish off. Negative 10 plus 8 over negative 6 is going to be negative 2 over negative 6, which is positive 1/3. And then negative 10 minus 8 all over negative 6 is going to be negative 18 all over negative 6, which is going to reduce to positive 3. So we're just going to check our answers using the graph. So we're up negative 3x up to the second plus 10x minus 3. And if we look at our graph, our answer is 0.333 and 3. So we did get a 3, just to confirm that 3.333 is 0.333 is 1/3. We just do 1 divided by 3, and we can see that 0.333 is the same as 1/3. So hopefully this helps you understand how to solve quadratic equations using quadratic formula and just verify with the graph. I'll see you in the next video where we find complex roots of quadratic equations using the quadratic formula.